Friedhelm Rodermund. I'm working for Vodafone Group R&D. Current focus is M2M standards and IoT standards. So, why am I showing the Vodafone footprint? It's not for advertisement reasons, just to illustrate. Vodafone is a big M2M service provider, providing services across many countries, different verticals, automotive, industry, health, energy, dealing with thousands of different devices and many different device types, different services. And also for Vodafone it would be beneficial, and Vodafone is aiming to moving further towards the usage of standards also at the service layer. This is for reducing costs, development costs, reducing time to market, reducing device costs, increasing interoperability. So there are many benefits with this. But now Vodafone, as any other M2M service provider, is faced with this. So you have many committees and alliances in the M2M IoT space, and it seems that like every month a new one is popping up. And not all consortia are mentioned here. This is just a fraction. They would not fit all on this one single slide. Just let me go through some of them, explain you what they are doing. The ETSI has been active in the standardization for the M2M service layer, of common M2M service layer functions since quite some time. They created in TC-M2M, they created an end-to-end framework, which then was taken over 2 years ago by one M2M, EU standards organization. And there was a successor committee, which is still active, which is very active now. It's called Smart M2M, ETSI Smart M2M. This is now focusing on smart city, in particular on smart city applications and services, also taking into account regulatory requirements from the EU. Furthermore, you have in ETSI the ITS, the Intelligent Transport System, which is dealing with automotive standards. Many car manufacturers are present in that committee. So even in ETSI alone, you have several committees dealing with M2M and IoT standards. Then you have the one M2M, which has been founded, I think, like 2 years ago, by 7 standards organizations from the US, from Europe and Asia, creating a common service layer. And they are just in the process of finalizing their first release of specifications. The All Seen Alliance, quite new, a new member, or a new consortium. Also, it includes the All Join framework, which is a open source project with the aim to connect all the smart objects around you. They recognize each other. They can share resources. All Seen is mainly focusing on the smart home space. Continua is developing or has developed a system of connected health devices, health solutions. Oasis is the home of the MQTT, the message queuing telemetry transport protocol, which is very much used in the IoT space. It's a lightweight transport protocol with a publish subscribe model. It's been rolled out since many years, originally created by IBM. Of course, the IETF plays also a prominent role in the IoT space, having developed large parts of the internet protocols. Now, in the IoT space, they have developed the constraint application protocol, which I will explain later on. They have also developed 6LoWPAN, IP6 version 6 based low power meshed network standard. And they have developed the DTLS, the datagram transport layer security, which is used, for example, with lightweight M2M. The Home Gateway Initiative, as its name says, is focusing on home gateway specifications. IPSO Alliance we'll have a separate presentation later on, is creating smart objects, IP smart objects for the Internet of Things. And the Eclipse has an open source organization which has a dedicated IoT working group. We'll also have a separate presentation later on. And then another rather new organization, the Open Interconnect Consortium, creating specifications, open source projects, and a certification scheme for the network of everything, they call it. Fred, focusing on smart home, like smart home devices like thermostats and other devices. And the Industrial Internet Consortium, also quite new, trying to promote common practices or best practices, identifying best practices and promoting them for the usage of the industrial internet. So this is just a subset, as I mentioned. There are many more. There's IEEE activities are just starting. The GSMA has a connected living program. So these organizations, they're all doing great work. But there is a problem, of course, that it causes also some fragmentation of the market, and too much fragmentation will slow down the market development of IoT market and M2M market. So this is also quite a risk in having too many of these great organizations. However, we see some convergence in some areas. We see that some organizations are not completely working separate from each other. They are reusing technologies developed by other consortia. So there's some convergence which is good. Example, Live at M2M, developed by the OMA, is being used by 1M2M. It's part of the common service layer developed by 1M2M. It's one of the options for the device management protocol in 1M2M. But recently, 1M2M started work to integrate Live at M2M deeper into their common service layer framework, into their architecture. We have the IoT, which we'll explain later, the open source projects related to Live at M2M, the server side and the client side. We have the IETF, which has given the transfer layer for Live at M2M, which has created Co-op, which I will explain later on. And we have the IPSO Alliance, which is developing objects which are also compatible with Live at M2M, mainly for smart city applications. So it's good to see that several organizations are kind of converging on a technology. There might be more in future. It's too early to say whether these organizations like Continue or Open Internet Consortium will adopt Live at M2M, but there are discussions ongoing, in particular between Continue and OMA, how to use the Live at M2M protocol for managing the health gateway and health devices like blood pressure or blood sugar meters behind the gateway. So what I wanted to bring across is that more and more organizations are recognizing the benefits of Live at M2M. So what are the benefits? Ideally, we should have a standard which is horizontal, which can be used across all verticals, automotive, energy, industry, whatever. And it has to be easily extendable. So if you have an application in any of these verticals which you want to use it for, you should be able to easily make it usable for that application. Second bullet is to have a single protocol for device management, consisting of firmware upgrade, connectivity management, and application management, which allows you to control street lights or any kind of machinery. In particular for constrained devices, it would be very nice to have it in one protocol. Today you have often used separate protocols, one for device management and one for application management, and this can cause conflicts. And of course it requires a larger footprint on the device regarding CPU power and memory. Third point you want to have a highly efficient protocol which reduces the traffic. You have a growing number of devices. Maybe in 2020 we predicted, I don't know, 30 billion devices connected, and then the networks have to be able to handle it. So it's very important that the traffic is very optimized, but also the power consumption is also a topic for many smart objects which don't have power connected all the time. Point number 4 is the device cost. To enable a mass market, you need to bring down the device costs. Device costs are still too high. They might be acceptable for many enterprises, but if you want to make IoT business and business really successful, we have also to look beyond the enterprise into the consumer domain. And there it's even more important that the prices go down for consumers, for the consumer market. The next point is about security. Security is, of course, paramount in IoT. So IoT will not be successful if security is not addressed in the right manner. If you have more and more devices connected in your home, somebody hacks your fridge, you might get into trouble. So finally, developers. Developers are the kingmakers here. The solution has to be developer-friendly, otherwise it will not be successful in the market. And yeah, obviously this is a marketing slide, and OME Lightweight M2M gives you all these points combined. I think really it makes it kind of unique in the market that you have all these different benefits combined in one solution, in one protocol. Moving on, how does it work? So how Lightweight M2M works? Some technical basics might not be so interesting for some of you who have been at the ongoing test event. You know already how it works, but we have many people out there who are keen on an introduction on Lightweight M2M. So Lightweight M2M uses as the transport protocol, the constrained application protocol, CoAP. Is this the wrong number theory? Is this the wrong RFC number?
Yeah, it's 7252.
7252, so there's a typo here. This will be corrected in the slide, which will be available for download later on. So the constrained application protocol brings the web model to IoT. It's a RESTful protocol. It uses HTTP verbs like get, put, post, and delete. It has, you can say, two kinds of QoS, a confirmable and a non-confirmable mode, which also ensures reliable transfer across UDP. It's because it was designed to run over UDP. It has specific M2M functions, basic functions included, such as a subscribe function. You can subscribe to a, no, it's called observe, right? In the CoAP terminology, observe a sensor function, for example, and you get an update when this value changes. You get an alert. And it uses the data transport layer security. And simple comparison, HTTP versus CoAP shows you CoAP can have a header which is only 4 bytes. So it's really small, and also the flow, the message flow is much lighter compared with HTTP, so it brings lots of benefits. And then coming to the architecture, on the right hand side you see the protocol stack. Starting from the bottom, you have UDP as a bearer, but you can also use SMS. And CoAP secured by DTLS can be run over these two bearers right now. On top you have the Lightweight M2M framework, which includes in particular the object model, which I explain later. Lightweight M2M, on the left hand side you can see is the server client protocol. I will explain the 4 logical interfaces: bootstrapping, registration, object resource access, and reporting on the next slide. Lightweight M2M server has access to web applications or device management applications on the top. Moving to the 4 logical interfaces. First one is about bootstrapping. You need to tell the device which Lightweight M server it should talk to. And it can also talk to several servers for splitting up the functions provided by a device. You might have one server who's used for device management purposes only, the other server is used for the application. They both could speak to one device. So bootstrapping tells the device which server to talk to and provides it with the right security credentials. After the device is bootstrapped, it is able to register with the server. So it tells the server, hey, I'm here, you can use me. And then you have the management and service enablement interface, which provides the main device management service and application management functionality, like device management functionality, like configuring the connectivity, the APN, checking the available memory, or the power connection mode, or the battery level. Then you have the information reporting interface, which uses the observation function to provide updates of certain values, sensor values. You can put thresholds, for example, and if the threshold is reached when you get an alert from the device to the server, hey, my petrol tank is below a certain limit or whatever. You can have periodical reporting. You can also configure periodical reporting. So this is a quite powerful alerting mechanism which is included on this information reporting interface. And one of the strengths of Live at M2M is the object model. The functionality, you can say, is grouped into objects. For example, you have a firmware object, you have a connectivity management object, you have a location object or sensor object. And each object consists of several resources which are required to provide the functionality. For example, the firmware object gives you a resource into which the server can write the download URI, so the client knows where to find the firmware update. And then you have another resource in the firmware object which allows you to execute the installation of the downloaded firmware. Another resource in the firmware object allows you to retrieve the result of a firmware update, whether it was successful or non-successful. So the resources in a certain object provide the functionality you need for this specific function, which is represented by the object. And the client has at least one, but normally it has several objects. And the resources in such an object, they are accessed by the server via simple get, put, post, delete commands, addressed via URIs. In the example on the right-hand side, you see a simple get operation. Get 1/1 means get object 1, resource 1. And in this case, the object 1 represents the Live at M2M server object, and the resource 1 represents the registration lifetime, which is then returned by the client to the server by this get command. In that particular case, it could also be a put command, so we can also change the registration lifetime by the server. And the great benefit is that everybody can create new objects. So if you have a new application you want to provide and you want to use Live at M2M for, you can create a new object. You can create an object for your fridge or whatever kind of application you want to do, and you can ideally you would register it. You would register this object with the OMA to get a unique object ID, because this is what ensures interoperability. If a server supports your object, it will recognize by the object ID which functionality is behind this object ID and which resources are included. So therefore, we have the registry of the object IDs provided by the OMA, and so it's not a standard which gives you just a limited set of functions which can never be extended. It's really very open, and you can create it or use it to provide any kind of IoT and M2M application. So what do we have today provided by this object? As I mentioned, you have a bootstrapping function. We have device configuration function. We have firmware update now being extended by software management. We had the OMA meeting last week in Budapest, where more objects were agreed. We have diagnostics functions such as checking the battery status and also doing, for example, you can also do a reboot of your device if there is a problem. Or if after a firmware update you can trigger a remote reboot. Connectivity management, then remote control is very wide area, which might be to a large extent also covered by organizations outside OMA. OMA so far has been focusing in the first set of objects on device management functionality, whereas organizations such as IPSO are going beyond that, and they are providing functions related to the actual application, providing objects related to the actual application. You have a data reporting function, and you have also a log and wipe function, which allows you to wipe the memory in case the device is stolen, or to log it to make it unusable. As I mentioned before, security is extremely important, and the OMA Live@M uses the datagram transport layer security across UDP, but also across SMS. So this is the list. Oh, my time is almost up. I have to hurry, I guess. This is the list of objects which has been part of the first 1.0 release. The functionality I already mentioned earlier, except maybe a location I didn't mention yet. Location information can also be provided. And this is the new objects which have been created or finalized last week, log and wipe software management. Then you have 4 objects related to connectivity management, the cellular network connectivity, APN connection profile, the wireless LAN connectivity, and bearer selection. Bearer selection object allows the server to tell the device which bearer it should use, preferably. It would have several bearers available. For example, should it use Wi-Fi or should it use cellular? If cellular, which kind of cellular, LTE preferred or 2G preferred, 3G? So we can configure this remotely on your IoT M2M device. And you have capability management, which allows you to remotely enable and disable certain functions on the device, like switching off on GPS or like turning on off attached devices, like any kind of machine which is attached to your M2M module. You can control with the capability management object. IPSO Smart Alliance is creating objects which will be explained later on in a separate presentation. OMA is also doing some work on the Northbound Interface, providing an interface, APIs to the service from the service layer to the M2M, Live@M2M server. This is also work which also includes interface to the OMA DM server. So this is work about the Northbound Interface. Requirements have been agreed. Then OMA is just creating work on defining to better support the gateway concept in Live@M2M. That has been started last week. And then we are thinking of, or we're planning to, for the next OMA meeting in June in Miami, to kick off the next release of Live@M2M 1.1, which will provide or aims to provide several enhancements to the Live@M2M protocol. For example, TCP support could be one option, has been suggested by some companies. There are some IETF work which provides security enhancement. There might be some alignments needed also in Live@M2M to be consistent with that. SMS security enhancements have been discussed. Peer-to-peer support between clients. Imagine a motion detector talks directly to your camera, and if it detects the motion, it switches on the camera, and such things could also be enabled by Live@M2M. Gateway support I already mentioned, and then object versioning. So far we had the original set of objects doesn't include a versioning concept, but if you want to extend existing objects, then we might need to have a versioning concept. So your input is welcome. Any ideas are welcome, and please bring them to OMA. Finally, growing ecosystem. just want to briefly mention, OMA is evolving live at M2M further, new objects, protocol extensions, IPSO Alliance is defining objects, Eclipse Foundations is running successful open source projects. OMA is developing also a test suite which has been used or is still be used at the test phase this week, but this test suite could be enhanced by more test cases, and you could also introduce a certification scheme, for example, by the Global Certification Forum. These are just ideas, nothing has started yet, but I think that would be quite useful. We have test events being organized, and this is the biggest one so far with 15 implementations at the test event. And finally, that's also why we are here today, OMA developing Porter SDKs for supporting the Live at M2M developer community. So that's good to see that this ecosystem is really taking off. Finally, my time is up. Some useful links on the last slides. We have the white paper mentioned here, which gives you an introduction to Live at M2M. You have the specification and some other material which could be useful. So, thank you very much for your attention.